At exactly 1 in the afternoon on June 5, 2026, NASA Mission Control in Houston issued an order to the astronauts aboard the International Space Station. Put on your spacesuits. Move to the escape vehicle. Prepare for evacuation, not a drill. Not a precaution communicated gently through routine channels. An emergency order issued in real time to 5 human beings living 250 miles above the surface of the Earth. For the next 2 hours, those astronauts sat inside a docked SpaceX Crew Dragon capsule, suited up, buckled in, watching data on screens while engineers on the ground tried to figure out whether they needed to leave. 2 hours later, Mission Control gave the all clear. The astronauts unbuckled, took off their suits, went back to work. And NASA released a statement that used the phrase safe haven procedure and called the situation a precautionary measure. Precautionary measure. 5 astronauts in spacesuits inside an escape vehicle for 2 hours is not a precautionary measure in the way that wearing a seatbelt is a precautionary measure. It is what you do when the structure keeping humans alive in the vacuum of space might be failing around them and you need them positioned to leave in minutes if it does. And here is what the official statements are not fully explaining. This was not the first time. This was not the second time. This was not even close to the beginning of the story. The International Space Station has been slowly losing air since 2019. 7 years. And the situation has been getting worse. Not better despite years of repair attempts, sealant applications, crack hunting operations, and engineer consultations between NASA and the Russian space agency Roscosmos. The leak that triggered the June 5th emergency is coming from a specific section of the station called the PRK Transfer Tunnel, which is a small connecting vestibule attached to the aft docking port of Russia's Zvezda service module. Zvezda is one of the oldest components of the station. It was launched in the year 2000. It has been in orbit for 26 years. It is the module that provides living quarters, life support systems, flight control, and atmospheric management for the Russian segment of the station. It is also the module that has been cracking. The first hairline cracks were detected in 2019. At the time, NASA and Roscosmos both described the leak rate as small and manageable. Russian crews applied sealant. The situation appeared to stabilize. Then in 2020 and 2021, the cracks came back. More sealant was applied. 2 specific crack locations were sealed in March 2021. The pressure continued to drop. By 2024, the NASA ISS Advisory Committee released a report noting that Russian and American technical experts disagreed on the underlying cause of the cracks, not on the repair approach, on the fundamental cause. 2 space agencies with their best engineers looking at the same structure for 5 years, and they could not agree on why it was failing. That is not a minor disagreement. That is a serious red flag about what is actually happening to the oldest and most critical module on the International Space Station. In early 2026, the leak appeared to stabilize again following additional repair work. A commercial spaceflight mission called Axiom Mission 4 was given clearance to proceed after engineers confirmed the pressure appeared to be holding. It was not holding. On June 1st, 2026, Roscosmos detected a higher leak rate during routine cargo operations involving a Progress resupply spacecraft. The leak rate had increased to approximately 2 pounds of air per day. 2 pounds of air per day sounds like a small number until you understand what it means inside a sealed structure where every molecule of atmosphere has to be either brought from Earth at enormous cost or generated by onboard systems that were designed to replace normal losses, not to compensate for structural failure. The systems were keeping up, barely. But the direction of the leak rate, increasing, not stable, not decreasing, was what forced the decision on June 5th. When Russian crew members attempted a high-risk repair of the worsening crack location inside the PRK tunnel, the situation became unstable enough that Mission Control made the call. Spacesuits on, move to the Crew Dragon, be ready to go. Think about what that decision actually means for the people who made it and the people who received it. The Crew Dragon capsule docked at the station can carry the crew back to Earth in an emergency. An evacuation would mean firing the capsule's thrusters, undocking from the station, and performing a deorbit burn that would bring the crew down through the atmosphere and splash down in the ocean somewhere. The whole process from undocking to splashdown takes several hours. It is not instant. It is not comfortable. And it means leaving the International Space Station unmanned, uncontrolled, and dependent on automated systems to maintain its orbit while ground crews figure out what to do next. An unmanned, leaking space station 250 miles above Earth is one of the scenarios that NASA's contingency planning treats as a serious operational crisis, because a station that continues to lose atmospheric pressure with no crew aboard to monitor and respond is a station that can fail in ways that are very difficult to recover from. The all-clear came before evacuation was necessary. The repair was paused. The pressure appeared to temporarily stabilize. The crew was told they could remove their suits and resume normal activities, but the leak is still there. As of the recording of this video, the PRK transfer tunnel is still losing air. The repair attempt on June 5th was halted, not completed. Engineers are analyzing new data, trying to understand exactly where the cracks are propagating and what the structural situation looks like. A decision on whether to attempt another repair, seal off the affected section entirely, or escalate to emergency measures has not been publicly announced. And Axiom Mission 4, the commercial spaceflight carrying private astronauts and a crew member from the Indian Space Research Organization, who was supposed to conduct experiments aboard the station, has been delayed indefinitely, pending resolution of the leak situation. Now, let me give you the broader context for why this matters so much more than the official statements suggest. The International Space Station is 25 years old. It was designed with a planned operational lifespan of approximately 15 years. It has been in continuous operation for more than 25 years, operating well beyond its original design parameters. The decision to extend its operation beyond the original lifespan was made for practical reasons. There was no replacement ready. Building a new space station takes years and billions of dollars. The scientific research happening aboard the ISS was considered too valuable to interrupt. But physics does not care about practical reasons. Metal fatigues, seals degrade, welds develop stress fractures. Materials that have been exposed to the harsh environment of low Earth orbit for 25 years. Temperature swings of 300 degrees Fahrenheit between sunlight and shadow every 90 minutes as the station orbits the Earth 16 times a day. Continuous bombardment by tiny micrometeorites and orbital debris traveling at 17,000 miles per hour. Radiation levels that would be lethal to unprotected humans do not behave the same way they did when they were manufactured on the ground. The Zvezda module, the one with the cracking PRK tunnel, was launched in 2000, 26 years ago. It was designed and built in the Soviet era and launched in the early years of the Russian space program's post-Soviet reinvention. Its materials, its construction methods, its sealing systems were all state-of-the-art for the year 2000. They are not state-of-the-art for 2026, and they were not designed to still be in operation in 2026. NASA and its international partners officially plan to retire the International Space Station by 2030. That means 4 more years of operation beyond the current date. 4 more years of an aging structure, with known cracks that have been getting worse for 7 years, maintaining a breathable atmosphere for human beings in the vacuum of space. The question that the June 5th emergency puts directly on the table is this: can it actually do that? The leak rate before June 1st was described as small and manageable. The leak rate after June 1st was 2 pounds per day and accelerating. The repair attempt on June 5th was halted when the situation became unstable. The station is currently losing air at a rate that the onboard systems are compensating for, but that the engineers cannot fully explain or confidently predict. A structure whose failure rate you cannot predict is a structure whose safety you cannot guarantee. And there are currently 5 human beings living inside it. Let us talk about what it actually feels like to be an astronaut aboard the International Space Station right now. Because the official language of precautionary measures and safe haven procedures sanitizes something that is genuinely and viscerally terrifying. You are 250 miles above Earth. The nearest hospital is 250 miles straight down. The nearest breathable air that does not come from a machine is 250 miles straight down. The nearest solid ground that you can stand on without a spacesuit is 250 miles straight down, and the machine that is keeping you alive is cracking. You know it is cracking because you have been told it is cracking. You know the repair attempts have not fully worked because you can see the pressure readings and you understand what they mean. You know that on June 5th, someone in Houston decided the situation was serious enough to put you in a spacesuit and move you to the escape vehicle. You also know that the escape vehicle works. You practiced this. You trained for this. You know exactly what to do if the order comes to actually leave. But you also know that leaving means leaving the station, leaving the experiments, leaving years of scientific work, leaving behind the most complex structure ever assembled in space, floating unmanned and damaged until someone decides what to do with it. NASA has not released a detailed timeline for the next repair attempt. It has not specified what the new data from the June 5th repair pause revealed. It has not said whether the current leak rate is stable or still accelerating. The official updates have been carefully worded to convey that the situation is being managed without conveying the full scope of what managing it actually involves. There is a pattern here that anyone who has followed the ISS leak story recognizes. In 2019, the cracks were small and manageable. In 2021, additional repairs were needed. In 2024, NASA and Roscosmos disagreed on the fundamental cause. In early 2026, the situation appeared stable. On June 1st, the leak worsened. On June 5th, astronauts were in spacesuits inside an escape vehicle. Each escalation was described in language that minimized its significance. Each deterioration was followed by reassurances that the situation was under control. And the situation has consistently gotten worse over 7 years despite those reassurances. The International Space Station is the most expensive object ever built by human beings. Its total cost, including construction, launch, assembly, and operation, is estimated at over $150 billion. It represents the largest cooperative scientific and engineering project in human history, involving the space agencies of the United States, Russia, Europe, Japan, and Canada. It has hosted over 270 people from 20 countries. It has conducted more than 3,000 scientific experiments over 25 years of continuous human occupation. And right now, today, its oldest module is cracking. The repairs are not working. The astronauts have already been in spacesuits once this month, and the official plan is to keep it running for 4 more years. The Zvezda module cannot simply be replaced. It is structurally integrated into the station. Removing it and replacing it with a new module would require a level of on-orbit construction that has never been attempted for a component of this size and criticality. The alternative of sealing off the affected PRK tunnel section would eliminate one of the Russian docking ports, reducing the station's capability and complicating future crew rotation missions. There is no clean solution here. There is engineering under enormous pressure to keep a 26-year-old structure functioning in one of the most hostile environments in existence, long past the point its designers ever imagined. It would need to function, and behind all of the technical, language and official statements and carefully managed public communications is a simple and uncomfortable reality. The space station is aging in ways that cannot be fully controlled or predicted. The rate at which it is aging appears to be accelerating, and the people who know the most about its actual condition are the ones being most careful about what they say publicly. When the most knowledgeable people are the most careful about what they say, that gap between what is known and what is being said is itself information. SkyPulse is going to track every NASA update, every Roscosmos statement, every data release related to the ISS leak situation as it develops, because this is not a story that is going away. The next repair attempt will happen. The data from the June 5th pause will be analyzed and acted on, and whatever the engineers find when they look closely at the current state of the PRK tunnel will determine whether the International Space Station continues its mission or whether the most expensive and ambitious structure ever built by human hands comes to the end of its operational life earlier than anyone planned. 5. Astronauts are up there right now. They put on spacesuits 11 days ago and prepared to leave. They are still there. The leak is still there, and the question of what happens next has not been answered. SkyPulse will be here when it is. Subscribe. Turn on every notification. This story is not over. This is SkyPulse. Stay alert. We will see you in the next one.